In this lesson, we will discuss the problems of creep and of aquaplaning or hydroplaning. We will look at tyre wear and damage. We will examine the problem of tyre creep and see how it is monitored. To end the lesson, we will take a quick look at the process of retreading tyres. Aquaplaning or hydroplaning is a phenomenon caused by a wedge of water building up under the tread of the tyre and breaking its contact with the ground. Aquaplaning speed, measured in nautical miles per hour or knots, is the speed at which the tyre loses contact with the ground. It can be found by applying the formula aquaplaning speed equals 9 times the square root of p, where p is the tyre pressure in pounds per square inch, or aquaplaning speed equals 34 times the square root of p, where p is the tyre pressure in kilograms per square centimetre or bar. The possibility of aquaplaning increases as the depth of the tread is reduced. It is therefore important that the amount of tread remaining is accurately assessed. The coefficient of dynamic friction between the tyre and the ground will reduce to very low values, typically 0 when aquaplaning. Neither nose wheel steering nor braking will be effective when the wheels are aquaplaning. The heat generated between the tyre and the water, if the brakes are applied during aquaplaning, may be sufficient to melt the tread of the tyre. Here, you may try an aquaplaning calculation. Enter a tyre pressure between 50 and 300 psi. Calculate the aquaplaning speed and enter it in the box. Press Go to check your calculation. During your pre-flight inspection, tyres must be examined for cuts, bulges, embedded stones, metal or glass, signs of wear, creep and local sponginess. Cuts in the tyre penetrating to the cords render the tyre unserviceable. The cords will be recognisable as pieces of white fibrous material embedded in the rubber of the tyre. Whether the tyre can be repaired or must be renewed is governed by the depth of the cut. Bulges may indicate a partial failure of the casing. If the casing has failed, that is to say the fabric is fractured, then the tyre must be replaced. Any flat spots on the tyre tread, especially those caused by skidding or aquaplaning, must be examined with great care to determine if the fabric of the tyre has been weakened unduly. Foreign bodies, such as pieces of metal or glass or stones embedded in the tyre, must be removed, and the cuts probed with a blunt tool by a technician to ascertain their depth. Repair or renewal of the tyre is governed by the extent of the damage. If you are in any doubt about the serviceability of a tyre, have it checked before flight by a suitably qualified technician. The amount of wear that a tyre can be subject to varies with different tyre types. Some tyres have marker tie bars in the centre groove. On others, the centre groove, or the 2 grooves either side of centre, are used as wear indicators. Generally, pattern tread covers worn to the base of the marker grooves, or to the marker tie bars, for 25% of the tyre circumference, or plain tread covers worn to the casing cords, must not be used. For special high-speed applications, some tyres have a layer of fabric woven into the tread. These tyres will have reinforced tread printed on the sidewall. This fabric may become visible during normal wear. This is perfectly normal, and the tyre can continue in service with this layer visible. With the increased size of modern airports, taxi distances have also increased, thus increasing the amount of tyre wear and risk of damage. To minimise tyre wear, it is recommended that a speed of no more than 25 miles or 40 kilometers per hour should be reached during the taxi run. When a tyre is first fitted to a wheel, it tends to move slightly around the rim. This phenomenon is called creep, and at this stage it is considered normal. After the tyre settles down, however, this movement should cease. In service, the tyre may tend to continue to creep around the wheel. If this creep is excessive on a tyre fitted with an inner tube, it will tear out the inflation valve and cause the tyre to burst. Creep is less of a problem with tubeless tyres, as long as the tyre bead is undamaged and any pressure drop is within limits. Creep is less likely to occur if the tyre gas pressure is correctly maintained. In order to detect creep, 2 white lines, known as creep marks, are painted, one on the wheel and a matching one on the tyre. If the lines become misaligned, then the tyre is suffering from creep. Provided the marks overlap each other, the tyre can remain in service. If, however, the marks become completely misaligned, then the tyre must be changed. Many aircraft tyres that become damaged in service can be successfully repaired. Tyres of which the treads are worn out, flat-spotted or otherwise damaged, but of which the core body or carcass is intact, can be retreaded. Retreading and repairing aircraft tyres has been a common practice for many years, and can save aircraft operators considerable sums of money. Tyres can be retreaded or repaired for continued service at a cost much lower than that of a new tyre. EASA regulations require retreading and/or repairing of aircraft tyres to be performed in certified retread and repair stations by or under the responsibility of qualified and certified technicians. You should now have a good understanding of how much tyre wear and damage is acceptable. The aquaplaning formula is quite important, but probably more important is the fact that if the tyre is aquaplaning, then its coefficient of friction is at or near 0. You should understand the problems associated with creep and how it can be monitored. Finally, remember that an aircraft tyre whose tread is worn beyond limits can normally be repaired or retreaded many times.